Hello, I would like to say a few words about the error involved in numerical integration using Simpsons 1/3 rule, which actually states that if we integrate a to b fx dx using Simpsons 1/3 rule, we use the formula like this: y0 plus 4 into y1, y3 and these odd nodes plus 2 into y2, y4, y6 like these even nodes plus yn. This is the Simpsons 1/3 rule, and we would like to calculate the error involved in this formula. Now, in my previous video, I do beg a pardon that I have committed an inadvertent mistake while calculating the error involved in trapezoidal rule, where I have stated that the trapezoidal rule, in case of trapezoidal rule, a to b fx dx is given by h by 2 y0 plus 2 into y1 plus y2 plus y3 plus dot 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 yn minus 1 plus yn. Instead of writing this, I erroneously wrote in my previous video x0, x1, x2, x3 and x in place of y. That was a very inadvertent mistake, for which I do beg a pardon. Actually, what I wanted to mean is that the value of y at x0, the value of y at x1, but I should have written the exact formula, which was wrong in my previous video. So that's why I thought that I should upload another video involving error in Simpsons 1/3 rule. The idea or concept is same. So I do beg a pardon, and I again repeat that trapezoidal rule is given by this, and in my previous video I erroneously wrote x in place of y. Okay, now let us move on to calculate the error involved in Simpsons 1/3 rule by the same technique. We should remember that as in place of trapezoidal we used n equal to 1, and the interval a to b was subdivided with this type of subintervals. Here, in case of n equal to 2, this is the case in trapezoidal rule, and in case of Simpsons 1/3 rule, instead we have used n equal to 2, and we have x0 to x2, then x2 to x4, and so on, with the last one being xn minus 2 to xn. We have three nodes: x0, x1, x2, x2, x1, x2, x3, x4, then xn minus 2, xn minus 1, xn. And in case of trapezoidal rule, we used it as h by 2 y0 plus y1, then plus of y1 plus y2, then plus of, sorry, this is h by 2, then we have yn minus 1 plus yn, and when we add them up, it gives us the requisite formula, which I repeat, I am sorry to say that I erroneously wrote x in place of y in my previous video. This is trapezoidal rule, adding them up. And what is Simpsons 1/3 rule? it is nothing but a2b fx dx. If we write the formula for the part x0 to x2, it becomes h by 3, then y0 plus 4y1 plus y2. And that is why whenever we add this up, we have the formula for a2b fx dx as h by 3 y0 plus 4 into y1 plus y3 plus dot dot dot, all odd nodes, and these y2 get doubled, isn't it so? So y2 plus y4 plus dot dot dot, all odd nodes are added twice, x2 added, x4 added, and then x minus n minus 2 is also added. So all the odd nodes are multiplied by 4 and all the even nodes are multiplied by 2, and the extreme 2 nodes remain free multiplied with 1. So this is Simpson's 1/3 rule. Now to calculate the error, we should start from the scratch, just like trapezoidal rule. What we do, we write the formula for the zone or the interval, subinterval x0 to x2. Then, employing the so-called Taylor series expansion, we know that y1 is nothing but f of x0 plus h, and so it can be represented as this using Taylor series expansion. This is the expression of y1, isn't it so? And what is y2? Let's write y2 here. y2 is nothing but f of x0 plus 2h. So if we employ Taylor series expansion here, we have fx0 plus 2h f prime x0, and then we have 2h whole square by factorial 2, that is 4h square by factorial 2 f double prime x0. Then we have 2h whole cube by factorial 3, which is 6 f triple prime x0. Then we have 2h whole to the power 4, which is nothing but 16h to the power 4 by factorial 4 f4 x0. Now, if we write this value and this value here and add them up, see what we have. We use y0 and y0 prime in place of fx0 and fx0 prime. Fairly reasonable. So this is y0, and then you have y1 as this multiplied with 4. So it gives 4y0 plus we have 4h y0 prime plus we have 2h square y0 double prime. What is the next term here? The next term here is h cube by factorial 3. Isn't it so? f3 x0. So when you multiply with 4, it becomes nothing but 2h cube by 3 y0 triple prime. This is h cube and we are multiplying with 4. Here it is 6. So it is 2/3 h cube by 3. The next term will be y4. y4 is nothing but h to the power 4 by factorial 4. Factorial 4 is nothing but 24. Factorial 4, the term after this is h to the power 4 by factorial 4, and we multiply with 4. So it becomes h to the power 4 by 6 y04. Then we have these terms. So what is this? Is y2. So we have y0 here. Then we have 2h y0 prime here. Then we have 2h square. This is nothing but 2h square y0 double prime here. Then you have 8h cube by 6, which is nothing but 4/3 h cube. This is 4/3 h cube. So we have 4/3 h cube y0 triple prime here. And then we have, this is factorial 4 and this is 16. Factorial 4 is again, we should remember that it is 24 and this is 16. So when divided with 8, it becomes 2/3. So this is 2/3 h to the power 4 and y0 4. Okay, so I am wiping it out. And this is our, see that we have not written any terms beyond y0 to the power 4 for reason which will be apparent. So y0 is 6, so it is 2h y0 when multiplied with 3. y0 prime is also 6h, so this also becomes. Then we have 4h square y0 double prime, isn't it so? So this is 4/3 h square y0 double prime. And then we have h to the power 4 term. So when we add 2/3 and 1/6, what it becomes? 2/3 and 1/6. So this becomes 5/6. Sorry, we are committing a mistake. Here it is h cube. H cube is 2/3 plus 1/3. So 2/3 plus 4/3. Sorry, h cube is 2/3 plus 4/3. So 2/3 plus 4/3 is 2h cube. So the term is actually, this is 2h cube, and when multiplied with this, this becomes 2h to the power 4 by, actually I have written this erroneously, and this should be h square. When h multiplied with this h, it becomes h square, and this is h cube, and this becomes h to the power 4. That is why I committed a mistake. So this is nothing but 2, and we have 2h to the power 4 by 3 y0 triple prime. Now we have 2/3 plus 1/6, which we are calculating earlier. 2/3 plus 1/6. This is a very simple calculation, and this becomes nothing but 5/18 h to the power 5 y0 4 dot dot dot. So this is actually our IS, the value of the integral using Simpsons 1/3 rule. Now we intend to find the exact value of this integral. How we can do that? Obviously we will employ the same technique of expanding this in terms of Taylor series expansion. So let's see what is the exact value or true value. We may write IT. It's nothing but x0 to x2 fx dx, written as x0 to x2 f of x minus x0 plus x0 dx. Here this is h. So we may write this expansion as fx0 plus, we are expanding it around the point x0. So this will be x minus x0 into f prime x0. Then it will be x minus x0 whole square by factorial to f double prime x0. Then we have x minus x0 whole cube by factorial 3 f triple prime x0. And then we have x minus x0 whole to the power 4 by factorial 4 f4 x0. And not beyond that. The dx should be written here. Since we will compare this with this formula only, we stop here. And you integrate it term by term. Just see that all these fx0, f prime x0, f double prime x0, they are constant. And we replace them with y0, y0 prime, y0 double prime, and so on. So let us rewrite this as when we are interested about the true value, which is x0 to x2 and the expansion of f of x0 plus x minus x0, this is termed as h dx. We have nothing but x0 to x2 y0 dx plus x0 to x2 y0 prime x minus x0 dx plus x0 to x2 x minus x0 whole square. Here we have by factorial 2 and y0 double prime. Here we have y0 prime dx and so on. So let us term by term. Let us write term by term. What is the value of this? This is nothing but y0 into 2h, because when dx is integrated, we have x2 minus x0. And what is x2 minus x0? It is nothing but 2h. So we write it as y0 into 2h. Then we have y0 prime taken out of the integral. And integral x minus x0 dx gives x minus x0 whole square by 2, which is nothing but 2h whole square by 2. Isn't it so? Next we have this. So y0 double prime by 2 is taken out of the integral, being constant. And this gives 2h cube. What will be the next term? Obviously it will be y0 triple prime by factorial 3 into 2h whole to the power 4 by 4. Here also we have 2h whole cube by 3. Isn't it so? I forgot to write this. This is the value of the integral, this integral. And y0 double prime by 2 is taken out of the integral sign. The next term will be x minus x0 whole cube by factorial 3. So y0 triple prime by factorial 3 is taken out of the integral, and then x minus x0 cube dx is integrated, and then we put this value. So this gives 2h to the power 4 by 4. And the next term, or the last term, which we will use, because here also we have stopped after y0 4, becomes this. Okay, so let us see what happens when we subtract from this original value I2 IT minus IS. It is very interesting to look that this 2hy0 cancels. This also cancels because this is 4 by 2, which is 2. This is 2 cube 8. 8 by 2 is 4. So this also cancels. And here we have What is 2 to the power 4? 2 to the power 4 is nothing but this we may write as 16h to the power 4, and factorial 3 is nothing but this. So these 4 2's are makes it 2, and it becomes 2h to the power 4 by 3. So this also cancels out. So the first term which doesn't match is this. And what is the value? If we calculate it, here we have 2 to the power 5. 2 to the power 5. And here we have 4 into 3 into 2 into 1 into 5 in the numerator. Isn't it so? So 4 2 cancels this. And we have 4 by 15 here. So this is nothing but 4 by 15. And this is nothing but 5 by 18. And we have h to the power 5 y0 4. This can easily be calculated by taking 1/3 common. We have 4 by 5 minus 5 by 6. Isn't it so? 4 by 5 minus 5 by 6. So the and we have h to the power 5 y0 4. So let us write it clearly, boldly rather. We see that it true value minus is the value of the integral x0 to x2 fx dx. The difference between it and is becomes 1/3 4 by 5 minus 5 by 6 h to the power 5 y4. And if we subtract this, it becomes 30, and we have 24 minus 25 giving minus 1, and this we may write it as replacing b minus a by 2 in place of h, or otherwise if we calculate this is of the order, we should not forget writing y suffix 0 or the derivative of fx at x equal to x0. So this is the error term involved in case of Simpson's 1/3 rule. I am sorry for making the mistake in case of the previous video involving trapezoidal rule. I do beg a pardon. It should be y0 plus 2 into y1 plus y2 plus y3 dot 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 yn minus 1 bracket closed and then yn.